Welcome to Math with Mrs. Bibb. Today I will be reviewing questions from the first summer work assignment and then going over questions that you will encounter on the second summer work assignment. So here is a question from the first summer work assignment, and questions 1 through 4 on the second summer work assignment is like these questions. So you'll use Desmos again, and you will take this list of ordered pairs, and you will write yes or no beside them. No work needs to be shown. Just write number 1. Go ahead and write down this problem, and then write the list of ordered pairs, and then write yes or no beside of them. So let's do the first one. So go to the, hold on, sorry. Remember, the red one is your left or right movement. You always start back at the origin. If it's positive, you go right. If it's negative, you go left. The green one is your up or down movement. So if it's positive, you go up. If it's negative, you go down. But always start at the origin when you do these. So let's do the first one. Go to the origin, go left 2, up 2. Is that ordered pair in the intersection of the blue and the red? That answers no. Letter B, go back to the origin, go left 1, go down 5. 1, 2, 3, 4, 5. Is that ordered pair in the intersection? Yes, it is. 0, negative 2. Go to the origin, go nowhere left or right, go down 2. Is that ordered pair in the shaded region that intersects? No. 2, 7. Go to the origin, go right 2, up 7. 5, 6, 7. That one is not in any shaded region, so that's a no. Go back to the origin, go right 1, go down 4. And that one is, so yes. 0, 0. Is that in the shaded region? It's in the blue, but not in the blue and the red, so that's a no. And that's all you have to do for that first question. Questions 5 through 8 are new. You should have learned this in Algebra 1. If not, then this will be your first time seeing it. If yes, then this will be a review. So if you'll write down the goals, our goals are to rewrite one or both bases to get the bases to be the same. And here's a fact that you have to remember: if you have a fraction, then that means you have a negative exponent. So basically, this will be a quick example to show you what we're looking for. If we have 3 to the 5th power equals 3 to the x plus 1, then since those bases are the same, then the exponents are equal, and you can solve. So x would be 4 in that problem. But if you'll notice, all the problems 5 through 8, none of them have the bases the same. But I do notice, and I'm going to highlight in green, if you have a fraction, then that means you have a negative exponent. So here's a negative exponent, here's a negative exponent. Those are the only fractions I have. So when I get to those, I have to remember that that's a negative exponent. Now, let's talk about this other fact. I want to rewrite one or both bases to get the bases to be the same. So we're talking about working with exponents. What I try to do is look at the largest base, see if I can rewrite it as the smallest base. So let me look at number 5. 81. Can I rewrite that as 9 to some power? Well, 9 to the first power is 9. 9 to the second power is 81. So yes, I can rewrite 81 as 9 to the second power. Now, you have to remember, when you have exponents that look like this right here, power of a power is what that's called, you multiply those exponents. So that would be 9 to the 2v equals 9 to the v minus 3. Now, the bases are the same. So I'm going to highlight those. Our bases are the same. So that means our exponents are equal. That's going to be my equation that I'm going to write. 2v equals v minus 3. And solve that. Subtract v. V will equal negative 3. That's the answer to number 5. Okay, let's look at number 6. First of all, anytime you have a fraction, you need to make that base be a whole number. So my base is 4. And again, remember that's you have a negative exponent. 4 to the negative 1 is 1/4. So 4 to the negative 1 raised to the 1 minus 3k. Can I rewrite 64 with a base of 4? Well, 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So yes, I can rewrite 64 as 4 to the third power. So my bases are the same. The bases are the same. That means that my exponents are equal. And that one on the left that I highlighted, I am going to multiply. So, hold on, I'm going to separate these. So this would be negative 1 times 1 minus 3k equals 3. Distribute the negative 1, so negative 1 plus 3k equals 3. Add 1 to both sides. 3k equals 4. Divide by 3. K equals 4/3. That's the answer to number 6. Okay, number 7. Can I rewrite the bigger base as 25 to a power? So 25 raised to the first power is 25. 25 to the second power is 625. So no, I cannot rewrite 25 with a base, 125 with a base of 25. So that means I've got to rewrite both of the bases. Well, what number can I raise to a power and get both 25 and 125? That's 5. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. So I'm going to rewrite 125 as 5 to the third power and keep that negative 2a minus 3 and rewrite 25 as 5 to the second power. Got to switch colors. So now my bases are the same. Hold on. My bases are the same. So that means my exponents are equal. Okay, so 3 times negative 2a minus 3 is equal to 2. Distribute negative 6a minus 9 is equal to 2. Add 9. Negative 6a is equal to 11. Divide by negative 6. A is equal to negative 11 over 6. That's the answer to number 7. Number 8, I've got to rewrite that as 6 to the negative 1 power raised to the 3p equals 36. So can I rewrite the bigger base as the smaller base? So 6 to the first power is 6. 6 to the second power is 36. So yes, I can. I can rewrite, I'll go this way. Let me keep 6 to the negative 1 raised to the 3p equals 36 is 6 to the second power. So now I have the bases are the same, and that means my exponents are equal. So negative 1 times 3p is going to equal 2. Negative 3p is going to equal 2. Divide by negative 3. P will equal negative 2/3. That's the answer to number 8. So that's how you solve an exponential equation. And what you see here is the kind of work that I will expect to be shown. Let me go through. You can see where I rewrote and had bases to show how I figured out which one I rewrote as. Here for this one I did 25 first because that's a smaller base, and I was trying to rewrite 125 as 25 to a power. So then I had to switch to rewriting them both to a power. So all of this is the kind of work that I'll expect to be shown. Okay, so we are reviewing solving by elimination. I will solve the first one by eliminating y. I am going to multiply this top one by 2 and multiply this bottom one by -1. Let me tell you how I knew I was going to do that. 4 and 8. Thinking about the multiples of 4. 4, 8, 12. And then multiples of 8. 8. There's their least common multiple. So I'm going to turn both of those blue ones into an 8. And they are not opposites of one another, so I'm going to go ahead and multiply by -1 on the bottom so that they will be opposites. So now I'm going to distribute. I'm going to have 2 times 9 is 18x, 2 times 4 is 8y, 2 times -14 is -28. On the bottom, -18x, minus 8y, interesting, equals -28. So here's a special one. Positive 18x plus -18x is eliminated. Positive 8y plus -8y is eliminated. So I have nothing left on the left. And then -28 plus -28 is -56. So this is a special answer. Your two special answers are no solution and infinitely many solutions. How do you know when you have which one? Well, if you have no solution, then a false statement is left after you solve and your variables are eliminated. And if you have infinitely many solutions, then a true statement is left. So let's look at our statement that's left there. Does 0 equal -56? No, that is false. So then I know the answer to number 9 is no solution. Now let's try number 10. I'll write it in green. Okay, I'm going to do elimination, and I think it would be easier. Let's just eliminate x since I eliminated y on the first one. So multiples of 18. 18, 36, so on and so forth. Multiples of 9. 9, 18, so on. So 18 is my least common multiple. So what do I multiply 18 by to keep it 18? 1. What do I multiply 9 by to turn it into 18? 2. Are they opposites of each other? Yes. So I do not need to make one of these values negative because they are opposites of each other. So I have -18x plus 20y equals -2, just multiplying all those by 1. On the bottom, I have 18x minus 20y equals 0. And look at that, both of these are end up going to be special answers. -18x plus 18x goes away, eliminated. 20y plus -20y, eliminated. So I have nothing on the left. -2 plus 0, -2. Is this a true statement or a false statement? It's false, so the answer is no solution. Interesting. Okay, moving on to the next one. I'm going to use substitution. My advice is to pick a variable that does not have a coefficient. This one doesn't have a coefficient. This one does not have a coefficient. So get that variable alone. All right, so I'm going to get y alone by adding 2x. So y will equal 2x plus 12 or 12 plus 2x, however you want to write that. And then you're going to substitute this expression in for y in the other equation. So 7x plus 4 times 2x plus 12 equals -12. Distribute 7x plus 8x plus 48 equals -12. Combine like terms on the left. 15x plus 48 equals negative 12. Get 15x alone by subtracting 48. 15x equals negative 60. Divide by 15. X equals negative 4. So this one was not a special solution. Now, when I'm doing substitution, I think it's easiest to take this answer back to where I isolated. So I'm going to take it back to there. So y is going to equal 2 times negative 4 plus 12. So y will equal negative 8 plus 12. So y is positive 4. That's the answer to number 11, negative 4, positive 4. Now let's try number 12. I'm going to add 5x to get that y alone. So y is going to equal 5x minus 6. I am going to substitute 5x minus 6 in for y in the other equation. So I'm going to have 2x minus 4 times 5x minus 6 equals 6. I'm going to distribute 2x minus 20x plus 24 equals 6. I'm going to combine like terms on the left. Negative 18x plus 24 equals 6. I'm going to subtract 24. Negative 18x equals negative 18. Divide by negative 18. X will equal positive 1. So positive 1 is my x value. Now I'm going to substitute positive 1 back into here. So y will equal 5 times 1 minus 6. So y will equal 5 minus 6, which is negative 1. So 1, negative 1 for that answer. Moving on to the next type of problems. Okay, so here we're going to read the word problem. We're going to define the variables, write the equations, and solve. So I'm going to go straight to defining my variables. Find the number, and here's how you do that. Look for the question. Find the number of students in each van and in each bus. So X is going to be the number of students in a van. And Y is going to be the number of students in a bus. I'm going to highlight the two sentences that make our equations. So the senior class at high school A rented and filled 14 vans, 5 buses with 262 students. High school B rented and filled 12 vans and 14 buses with 516 students. So my equations will be, looking at the green, 14x plus 5y equals 262. And for the yellow, 12 vans, so 12x plus 14y equals 516. Now, I'm going to do elimination because I think that would be easier. I'm going to eliminate x, but I got to do some thinking. I'm going to do multiples of 14. 14, 28, which is not a factor of 12. 28 plus 14, is that 42? It's not a factor of 12. Plus 14, is that 56? Not a factor of 12. Plus 14 is 70, not a factor of 12. Plus 14 is 84, which is a factor of 12. 12, 24, 36, 48, 60, 72, 84. So I'm going to multiply the top by 1, 2, 3, 4, 5, 6 by 6 and multiply the bottom by 1, 2, 3, 4, 5, 6, 7 by 7. And they're not opposite, so I'm going to make the top a negative. So 14 times 6 is 84x. Oh, a negative 84x. Oh, hold on. Negative 84x minus 30y equals 262 times 6. 36, 37, 12, 34, so 1572 negative. Negative 1572. And then 7 times 12 is 84x plus, is that 98? 98y equals, I gotta multiply, 42, 7 times 1 is 7 plus 4 is 11, 36, 12. I'm going to add negative 30y plus 98y would be positive 68y, and then 3612 minus 1572. 0, 11, 5, so this would be 4, 0, so 2040. 2040 divide by 68. What can I multiply by 8 to get a 0? That would be 5. Did I subtract one wrong? 3 minus 1 is 2. Let's multiply. So 68 times 5. Oh, and you can use a calculator. So it's Algebra 2 honors. You can use a calculator. I need to grab one and do that. 5 times 8 is 20. Okay, so I'm going to grab a calculator just because I'm hoping my other math is right. 2040. Oh, I did 5040. Oh, okay. 2040 divided by 68 is 30. So y will equal 30. And then to find x, I'm going to put y in the top one. I'm going to, in fact, if it'll let me, I'm going to erase, and it won't let me. Oh, it'll let me do this one. Seems like after you've done it, like been away from it for so long, it won't let you erase. Let me do that. Nope. Okay, it's fine. Okay, so 14x plus 150, 5 times 30, equals 262. So 14x equals, and I'm just going to use a calculator. I could do it with my own brain, but it'll be faster. 262 minus 150 is 112. So 14x equals 112. That 8? Yes. So x equals 8. Now we have to answer it properly. Here's where my final answer is going to be. So x is the number of students in a van. So there were 8 students in each van. And 30 students in each bus. And that's the answer to number 13. Moving right along. Number 14, I'm going to define my variables first. I'm going to highlight that last. I'm just going to go to the last underline it. The question, what is the cost of one daylily and the cost of one pot of ivy? So x is the cost of one daylily. And let's use x or y's. And y is the cost of one pot of ivy. Okay, let me highlight so we'll know who did what. Telling you they bought at the same stores just to help you know that the prices would be the same. Okay, so 10 daylilies plus 5 pots of ivy would equal $140. 3 daylilies and 8 pots of ivy equals $120. And let's get rid of y again. The multiple they'd have in common would be 40. So I'll multiply the top by 8 and the bottom by 5. And I'll multiply the top one by negative. So negative 80x minus 40y equals, we'll use a calculator. 40, I should know that. Negative 1,120. And 15x plus 40y is going to equal, what's that, 600? Yeah. Okay, I'm going to add negative 80 and 15 is negative 65. Yes, negative 65x. The y's are eliminated, equals 1120 minus 600 is negative 520. Divide by negative 65. I can't type in the right numbers. That's 8, so x is going to equal 8. And to find y, I'm going to put it in the top one. So 10 times 8 plus 5y equals 140. 80 plus 5y equals 140. Subtract 80. 5y equals 60. Divide by 5, y equals 12. Okay. All right, so y is 12. And my final answer, each daylily costs $8, and each pot of ivy costs $12. And that's the work I'll expect to be shown when you do those. And you're welcome to do substitution for one of them if you prefer substitution. I just prefer elimination, so that's why I did elimination. Moving right along, we're going to simplify. So hopefully you can tell that with the first two, we are adding. And with the next 4, we are multiplying, because those parentheses are side by side, so we're going to multiply. We're going to use a distributive property to multiply. For 15 and 16, there's really no work you can show except to write down the original problem. We're going to add like terms. Oh, let me do a different color. So we'll put the x to the fourths together. We'll put the x's together. And we'll put the constants together. And you want to go with the biggest exponent first. So, biggest exponent is the fourth, so 7x to the fourth. The next would be the blue, negative x plus 2x is positive x, and then plus 8. That's my answer to number 15. Number 16, let's highlight again. We're going to put the b squareds together. We're going to put the constants together. There's nothing to go with this one. And there's nothing to go with that one. And we'll go with largest exponent first. So my largest exponent is 7b to the fourth. Next would be 9b to the second. Then minus 6b, and plus 5. That should be the answer to number 16. Now for 17, we are going to distribute. We're going to multiply x times 4x minus 7, and minus 2 times 4x minus 7. So x, this is how you show your work. x times 4x minus 7, and minus 2 times 4x minus 7. You don't even have to write the original problem on your paper. You can go straight to this. And then distribute 4x squared minus 7x minus 8x plus 14. Combine your middle terms. 4x squared minus 15x plus 14. That's my answer. For the next one, I'm going to multiply 2x and 4x minus 2 and negative 5 and 4x minus 2. So 2x times 4x minus 2 and negative 5 times 4x minus 2. So 8x squared minus 4x minus 20x plus 10. Combine your middle terms. 8x squared plus 24x plus 10. That's my answer to number 18. You're going to do the same thing for the next one. You're going to multiply 6p with 3p squared minus 8p plus 8 and negative 4 times that same thing. So that's what we're going to do. 6p times 3p squared minus 8p plus 8 minus 4 times 3p squared minus 8p plus 8. Distribute 18p to the third minus 48p to the second plus 48p minus 12p to the second plus 32p plus 32. Combine like terms, nothing to go with 18p cubed. Negative 48p squared and negative 12p squared is negative 60p. Positive 48p and positive 32p is positive 80p plus 32. That's my answer to number 19. And number 20, I'm going to multiply 4x times 8x squared minus 3x minus 4 and negative 5 times 8x squared minus 3x minus 4. So 4x times 8x squared minus 3x minus 4 minus 5 times 8x squared minus 3x minus 4. Then I'm going to distribute 4x times 8x squared is 32x cubed. 4x times negative 3x is negative 12x. 12x squared, 4x times negative 4 is negative 16x. Negative 5 times 8 is negative 40x squared. Negative 5 times negative 3x is positive 15x. Negative 5 times negative 4 is positive 20. Nothing to combine with 32x cubed. Negative 12x squared and negative 40x squared is negative 52x squared. Negative 16x and 15x is negative 1x plus 20. And that's the answer to number 20. Moving right along. Next, we're going to factor using the area model. Remember, you make a square. In your square, p squared, the first term goes in the first box and negative 6 goes in the last box. I know that p times p is p squared, and factors of 6 are 1 and 6 and 2 and 3. And I know that one of these has to be a negative. So, and I know also that since this is a positive, that the bigger one has to be positive. So I'm going to put 6 here and 1 here and see if that'll work. Negative 6 times p is negative 6p. P times 1 is 1p. And do these two add up to give me this? No. So that's not my answer. I'm going to undo all this. Now I'm going to try, the bigger one has to be positive, so positive 3 and negative 2, and then I'm going to multiply. Negative 2 times p is negative 2p. P times 3 is 3p. 3p and negative 2p, is that 1p? Yes, it is. So my answer is, don't forget, p minus 2 times p plus 3. It's what's along this side. So p minus 2 times p plus 3 is the answer to number 21. Number 22. I need to make my area model. The first term goes in the first box, top left. The last term goes in the last box, bottom right. I know x times x gives me x squared. So 40, my factors are 1 and 40, 2 and 20, 3 and 10. No, 3 doesn't go. 4 and 10, sorry. 4 and 10, 5 and 8. Okay. I want these two to add up to give me negative 13. And they have to multiply to give me positive 40. So they both have to be negative. And let's see. 5 and 8. Negative 5 and negative 8. You could try all those, but I just mentally went through them. Negative 5x, negative 8x adds up to give me negative 13x. So my answer is x minus 5 times x minus 8. That's the answer to number 22. Now, moving right along. If you will draw this chart on your paper and write this down because it's very, very important to follow these steps when you're factoring. Step 1, you have to do that every single time. To be completely factored, you have to take out the greatest common factor first. And then step 2, you have to ask yourself, do you have a binomial? If you have a binomial, you look for difference of squares. Do you have a trinomial? That trinomial has to be in one of these forms. If it's not, you can't factor. If it is, then you follow the rest of the instructions. And then if you have 4 or more terms, then you group with parentheses and take out the greatest common factor. So you'll want to pause and write that down. I'm going to go on to the next question, and I'll go through these steps with these next questions. Okay, so factor using the methods in the video provided in Google Classroom, which is this video here that we're talking about. So if you notice at the bottom of the screen, I have your factoring video. The first thing that we're going to do is look for a greatest common factor. Do 30k to the fourth, 78k to the third, and 36k to the second have a common factor? And I'm thinking it's 6. Does 6 go into 78? 1. Yes. So 6 is definitely the numeric common factor. And then k to the second. So you choose your smallest variable when you're doing your greatest common factor. If you need to write that down so you'll remember. You choose your numeric greatest common factor, and then you choose your, not smallest variable, smallest exponent. So make sure you choose the smallest exponent. Then you undo the distributive property. That's what factoring is. Undo the distributive property. So that's what I'm going to do. I'm going to show that I'm undoing the distributive property. So I'm going to divide each of these by 6k squared and put the answer in the parentheses. So 30k to the fourth divided by 6k squared is 5k squared. 78k to the third divided by 6k squared is 13k, positive 13k. 36k squared divided by 6k squared is plus 6. Now, next you look at this. Is this a binomial, a trinomial, or 4 more terms? Well, that is a binomial. Okay, so for that binomial, does that binomial fit one of these descriptions? Yes, it does. One of the biggest things is your middle exponent has to be half of the degree or the leading exponent, and it is. So it is in the proper form. Now, I'm pretty sure it does factor, so this is what I'm going to do. I'm going to come down here. I'm going to put 6k squared so I can forget about 6k squared and put 2 empty parentheses, and then I'm going to do what this says. Letter B says make a chart. It says name A, B, and C, make a chart. So A is 5. It's the first number. B is 13. And C is 6. I do expect to see you making A, B, and C and making this chart and factoring this way. So please make sure you do. Even if you're not writing this down for extra credit, make sure that you do follow these instructions. So A times C goes first. 5 times 6 is 30, and b is 13. So factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. Do any of those add to give me 13? Well, 1 plus 30 is 31. So that's not it. 2 plus 15 is 17. That's not it. 3 plus 10 is 13. So that's it. All right, so here's what you do. You replace 13K, so hopefully you can tell that's pink, with 3K and 10K. You rewrite it. Everything stays the same, except 13K becomes 3K plus 10K. 5K to the second remains the same, and plus 6 remains the same. 13K becomes plus 3K plus 10K. Now we have 4 more terms. So we group the first two together and put a plus sign and group the last two together. Then take out your greatest common factor from each group. The first group, K, is the only common factor. 5 and 3 do not have a numeric common factor. So that would be 5K squared plus 3. And then the next group, 2 is their greatest common factor. So 5K plus 3. And here's how you know, oh, I messed that up. Hopefully you saw that. This shouldn't be there. That should just be 5K. 5K squared divided by K is 5K. And with the reason why I noticed it is because these should be the same. If you have done it correctly, they should be the same. And they weren't until I just fixed that. And so you put what they have the same in the first one. And then mentally get rid of what they have the same. You don't have to scratch it out on your paper. And then that's what goes in the second set of parentheses, K plus 2. This is the answer to number 23. Okay, number 24. Do we have, back to step 1, do we have a greatest common factor? 7, 59, and 24? No. So is 7n squared minus 59n plus 24 a binomial, a trinomial, or 4 more terms? Well, hopefully you know that's a trinomial. It has 3 terms. Is it in one of these forms? Yes, it is. So you name A, B, and C, and you make a chart. Go make my chart right here. A times C, 7 times 24. And again, you can use a calculator. 7 4s are 28. 168. Factors of 168. That'll give me a sum of negative 59. Now, I want to multiply and get a positive and add and get a negative. So that means they're both going to be negative. And that is not the pair that I need. Negative 2 times negative 84. And that's not negative 59. Negative 3 times negative 5. 15. 18, 6. Negative 56. And negative 3 plus negative 56 is negative 59. So that's the pair that works. So I'm going to rewrite 7n squared minus 59n plus 24 by replacing negative 59n with negative 3n and negative 56n. So 7n squared stays the same, plus 24 stays the same. But negative 59n becomes negative 3n, and then minus 56n. And I'm going to group the first two together, put a plus sign, group the last two together. I am going to take out the greatest common factor, which is n for this first group. So 7n minus 3 goes there. The next group, I have to take out a negative greatest common factor because this is negative. So negative 8. Yes, negative 8. Divide both of these by negative 8. Negative 56 divided by negative 8 is positive 7n. 24 divided by negative 8 is negative 3. Are those two the same? Yes, they are. These are the same. So my answer is going to be 7n minus 3 times the quantity n minus 8. That's the answer to number 24. Number 25. Do I have a greatest common factor? 2n squared minus n minus 36. No, I do not. Is it a binomial, a trinomial, or four more terms? So hopefully you know it's a trinomial. Is that trinomial in one of these forms? Yes, it is. So I go on to letter B. If yes, name A, B, and C. A is 2. B is negative 1. C is negative 36. Factors of A times C, sum of B. So multiply, add. I want a negative sum, so my bigger one's going to be negative. So 1 times negative 72 does not work. 2 times negative 36 does not work. 3 times negative 24 does not work. 4 times something. Negative 18 does not work. 5. 6 times negative 12 does not work. 7 doesn't go. 8 times negative 9 does work. So I'm going to replace negative n with 8n and negative 9n. So I'm going to leave 2n squared the same. Leave minus 36 the same. And I'm going to replace negative 8n with plus 8n, negative n with plus 8n and minus 9n. I'm going to group the first two together, put a plus sign, group the last two together. Please reach out if you struggle with this. This is really tough, and this is when students resort to using resources that aren't what I expect you to do. So if you need help with this, let me know. I'm happy to help you. I'll walk you through it. Okay, this first group has 2n in common. Divide by 2n. So I'll be left with n plus 4. The second group has negative 9 in common. And I'll be left with n plus 4. So it did work. N plus 4 is the same in both of them. And 2n minus 9 is what's left. So that is my product to come up with the factorization of 2n squared minus n minus 36. Now number 26 has a common factor. It looks like 6. And no x because they don't all have x. So if you divide them each by 6, you get 3x squared plus 2x minus 5. So I'm going to bring this 6 down. Go ahead and put that there. And then I want to name A, B, and C because that is a trinomial that's in the right form. I'm going to make a chart. A times C, sum of B. One positive, one negative. Bigger, one positive. So negative 1 times 15. No. Negative 3 times positive 5. Yes. Okay, so I'm going to replace 2x with negative 3x plus 5x. So 3x squared minus 3x plus 5x minus 5. Group together with parentheses. Put a plus sign in the middle. The first group has 3x in common. Oops, no, x minus 1. Divide by 3x, divide by 3x. The second group has 5 in common. It worked, so I'm going to have 6 times the quantity x minus 1 times the quantity 3x plus 5. So if you can't see that 3x plus 5, it's because these are your greatest common factor and you take them away. These go there, just one of them. And that's your answer. Moving on to number 27. Do I have a greatest common factor? Yes, those terms have 3x in common. We'll divide them both by 3x. So that would be 3x minus 1. And then this is a binomial. Is this binomial a difference of squares? Which means that 3 and 1 are in this list. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. So 1 is in that list, but 3 is not. So that's not a difference of squares. This is my answer. The next one, do they have a common factor? Yes, I think it's 36, but I could be wrong. I think I'm wrong. That's 180. Six. It might be bigger than 6. I'm going to try. You might want to wait. So I know they both have x. I'm going to divide by 6x. I think it's bigger than that. I think it's 12. Yeah, I think it's 12. So 12x. Okay, so put 12x on the outside. And this would be 3x minus 10. Okay, this is a binomial, and it is a difference because that means subtraction, but 3 and 10 are not perfect squares. So this is my answer. 12x times the quantity 3x minus 10. Moving on to the last slide. All right, neither one of these have a common factor. I am going to name A, B, and C. A is 8. B is 71. C is negative 90. I want factors of a negative 720 that will give me a sum of 71. Good heavens, take me forever to find that. My mind immediately goes to negative 10 times 72, but that's not it. Negative 9 times 80. Is that it? Yep. That's it. So I found them right away. So I'm going to replace 71 with negative 9x plus 80x minus 90. Group the first two together. Put a plus sign. Group the last two together. Take out the greatest common factor from the first group. That's x. Take out the greatest common factor from the second group. That's 10. And it worked. These are the same. So I have 8x minus 9 times x plus 10. That's my answer to number 29. And number 30, I don't have a greatest common factor. So A times C. Wait, A is 9. B is negative 9. C is negative 70. 9 times negative 70 is negative 630. And negative 9. So my first thought is negative 10 times 63, which is negative 53, so I'm way off. No, positive 53. I'm still way off. Let me do some calculation. I'll talk out loud what I'm going to do. I just had to grab my calculator. Okay, so I'm going to do 630 divide, whoops, I've got the wrong number in there. 630 divided by 30 is 21. 30 times 21. And then if I make this negative, that would give me negative 630, and negative 30 plus 21 is negative 9. So that works. So you can type in your calculator until you find what works, but use your brain. I knew I had to go bigger than negative 10, so that's why I went to negative 30. So that's how you do that. All right, replace negative 9n with negative 30n plus 21n, and then bring down your minus 70. Group the first two together, put a plus sign, group the last two together. Take out 3n from the first group. That'd be 3n minus 10. Take out 7 from this next group. Yeah. And that would be 3n minus 10. And it worked because these are the same. So I have 3n minus 10, that quantity times 3n plus 7. And that's my final answer. That's all of them. So again, please reach out if you need help. I'm happy to help you.